A gaseous element has a density of 3.195 grams per liter at a temperature of 35.8 degrees Celsius and a pressure of 374.6 torr. Which element best fits this description? We're talking about describing an element as far as numbers go, atomic number or atomic weight generally. Two quickest ways to do that. We're not going to get the atomic number out of this calculation, but we can get the atomic weight, which is also, of course, the molar mass. So our problem is really asking us to calculate the molar mass of this gas in this container, and then from the molar mass, look at the periodic table, see which element's atomic weight most closely matches the molar mass that we calculated. Recall in lecture, we can easily calculate the molar mass of a gas using the ideal gas law equation. Let's quickly review that. PV equals nRT is our starting point, of course, for the ideal gas law equation. And the number of moles, we know how to do that. We can calculate the number of moles of any chemical, whether it's a gas or solid or liquid, as long as it's a pure substance. Take the mass weighed out, divided by the molar mass. And what we can now do is simply substitute this relationship in for N in our ideal gas law equation. And when we do that, we end up with PV equals mass times RT over the molar mass of the gas. Now, since we're looking to solve for the molar mass, we have to do a little bit of algebra, but that's not hard. Our molar mass then is simply going to be equal to the mass times RT over PV. So we have numbers for all of these, not necessarily the correct units, so we have to check that first. We'll just substitute in and we calculate the molar mass. Our mass is given with volume. Please note here, our compound unit of grams per liter is telling us we have a specific mass, 3.195 grams to be specific, in 1 liter. So this problem is telling us that our volume is equal to 1 liter. And in that liter we have this many grams. So those two are given to us, and those two units are okay. Our temperature, of course, is not okay. 35.8 degrees Celsius is not going to cut it. So let's convert that to kelvins. 35.8 plus 273.15 gives us 308.95. We need to round that to the first decimal place, so we're going to have 309.0 kelvins. Let's highlight that because that's the number we're going to want for temperature. We'll even label it T equals that value. We got a problem with pressure. Our pressure value here is given in torr. We need it in atmosphere, so we got to do a conversion. So let's do that. We got 734.6 torr. So let's take our 734.6 torr times 1 atmosphere over 760 torr. Our units of torr cancel, and we get a value of 0.9666 atmospheres. Let's highlight that in yellow as well, and let's put a letter P next to that so we know what we've got here. P equals. Okay, now we can substitute in, so let's just put our values in. Our mass, I already mentioned that. We have 3.195 grams, so we have 3.195 grams, not grams per liter. Mass only has grams as its unit. R given to you, 0.0821 liter atmospheres per Kelvin mole. Last term temperature, we highlighted it, 309.0 kelvins. 309.0 kelvins. We're done upstairs, go downstairs. Pressure, we have it highlighted there in the upper right corner. That is atmospheres. I don't know why these things keep disappearing on me. 0.9666 atmospheres. And our volume, we said, was 1 liter. Okay, so now we're good to go. Let's cancel our units. I can see liters are gone upstairs, upstairs, and upstairs, downstairs. Kelvin mole disappeared again. Let's put it back and cancel the kelvins. They're gone. The atmospheres are gone. Upstairs, upstairs, and upstairs, downstairs. We're left with, and let's highlight this, grams per mole. Notice we've got moles downstairs, upstairs. Grams is upstairs, upstairs. So we have the proper units. Now we can turn on our calculator, and when we do the math, we get a value of 83.8 grams per mole. 3 significant figures out of that because of our constant R. And looking at the periodic table, the element that most closely fits that is krypton, which is element number 36.